Section 3.1 continued, properties of parallel lines. In Section 3.1, Part 1, we identified special angles created by two lines and a transversal. Here we go a step further when the two lines being intersected by the transversal are parallel. And we start out with the corresponding angle postulate. If two parallel lines are cut by a transversal, then corresponding angles are congruent. We know what corresponding angles are. They are not adjacent angles. One is on the inside of the two parallel lines, one is on the outside, and they are on the same side of the transversal. If my two lines being intersected by the transversal are parallel, then these two angles are congruent. Therefore, if this would be 110 degrees, angle 2 would be 110 degrees. With that information, I could then determine all measures of angles inside of this diagram. I already know that I have vertical angles, and vertical angles are congruent. I have linear pairs, and I know that's two angles that are adjacent and are supplementary. Therefore, this is 70 degrees. And I know vertical angles. Again, I can do the similar process on the lower section. Vertical angles are congruent, so this is 110 degrees. Linear pairs make this 70 degrees, and again, vertical angles are congruent. Now that I've filled in for all the measures of my angles in this diagram, I can see all sets of corresponding angles are congruent. 110, 110, 70 and 70, 70 and 70, 110 and 110. Therefore, we can see that the corresponding angle postulate is a very powerful theorem. If I know two parallel lines are cut by a transversal, then angle 1 is congruent to angle 2, or corresponding angles are congruent. Our next theorem is the alternate interior angle theorem. If two parallel lines are cut by a transversal, then alternate interior angles are congruent. In the diagram, I have represented two parallel lines, and they are being cut by a transversal. I know that angle 1 and angle 2 are a set of alternate interior angles. And since these two parallel lines are cut by a transversal, by the alternate interior angle theorem, I know that these two are congruent. Therefore, if I would let this be 105 degrees, I know that angle 2 would be 105 degrees because of the alternate interior angle theorem. I can then determine a linear pair that this angle would be 75 degrees. And I also know by the alternate interior angle theorem that alternate interior angles are congruent. So if this is 75 degrees, this is 75 degrees. I could then proceed to find the measures of all the other angles by vertical angles and by linear pairs. On this slide, we have the alternate exterior angle theorem. If two parallel lines are cut by a transversal, then alternate and exterior angles are congruent. Here in the diagram, I have two parallel lines being cut by a transversal. Angle 1 and 2 are a set of alternate exterior angles. And by this theorem, I know that they must be congruent when my two lines are parallel. Therefore, if I let angle 1 equal 120 degrees, I know that angle 2 is 120 degrees. Again, by a linear pair, I can find this angle, which I know would be 60 degrees. And its alternate exterior angle would be here. And I know that they would be congruent because of the alternate exterior angle theorem. Up to this point, we've had the corresponding angle postulate, the alternate interior angle theorem, and the alternate exterior angle theorem. Each set of those angles are congruent when the two lines cut by a transversal are parallel. This theorem throws a little wrinkle into it, and this is the same side interior angle theorem. If two parallel lines are cut by a transversal, then the same side interior angles are supplementary, not congruent in this instance. So in the diagram, I have two parallel lines cut by a transversal. Angle 1 and 2 are same side interior angles. And because these two parallel lines are cut by a transversal, my same side interior angles are supplementary. Therefore, if I let this be 70 degrees, I know angle 2 is the same side interior angle to it, would have to be supplementary to that, which would be 110 degrees. I know that all sets of same side interior angles are supplementary. For example, I can prove that by a linear pair. If this is 110, this is 70, or also alternate interior angles are congruent. I can also say alternate interior angles are congruent. And if I check the other set of same side interior angles, 110 and 70, again, are supplementary. Therefore, if two parallel lines are cut by a transversal, then angle 1 and 2 are supplementary, and angle 1 and 2 here are same side interior angles. In this example, they want me to find the measure of each angle in the diagram. Here I have a pair of parallel lines and I have two lines intersecting them. These two lines are transversals to these two parallel lines. These two lines are also parallel, and they have transversals intersecting them. Therefore, I'm creating same side interior, alternate exterior, alternate interior, and corresponding angles. We also have our previous definitions of vertical angles and definitions of linear pairs. So we can find a lot of measures just with one angle given two sets of parallel lines. Here, I know that angle 135 is an alternate exterior angle to this angle. And since the two lines being cut by the transversal are parallel, I know that they are congruent. I also know that these are vertical angles. Therefore, this is 135 degrees. And I know that alternate interior angles are congruent when these two lines are parallel. So this is 135 degrees. I also know that these two are corresponding angles, and I know that these two are same side interior angles, and they must be supplementary. Therefore, 135, and this angle must be 45 degrees. Now I have alternate interior angles, which is also 45 degrees. Now I have corresponding angles, which makes this 45 degrees. And here I have 45 degrees, and this is corresponding angle to that angle, which is 45 degrees. Of course, I could find these measures multiple ways. I just chose this procedure to get them. You may choose any procedure as long as it's a valid theorem or postulate or definition to get that value. Now we can go to these sides of this transversal and in this parallel line, and I know here that this is a set of alternate interior angles. Since these two lines are parallel, I know that this is 45 degrees. Again, alternate interior angles. These two lines are parallel, 135 degrees. I also know that these are corresponding angles, and that would be 45 degrees. These are corresponding angles, therefore 135 degrees, all because the lines cut by transversal are parallel. To get these sets of angles, I can either use these angles or these angles. In either case, I can get the same values. Again, I know that these two are alternate interior angles, therefore congruent because the lines are parallel. Alternate interior angles, 135 degrees. And alternate exterior angles being congruent, 135 degrees. And alternate exterior angles congruent. Again, they want me to find the measure of each angle in the diagram. Here, I'm given 103-degree angle, and I know that these two lines are parallel, and this is a transversal. Here I have a set of alternate interior angles. If two parallel lines are cut by a transversal, then alternate interior angles are congruent. Now I have these two pair of lines that are parallel. Here, I have a transversal that intersects two parallel lines. Therefore, same side interior angles are supplementary. So I know that this has to be 77 degrees. In this case, I have another set of parallel lines. If two parallel lines are cut by a transversal, then corresponding angles are congruent. Therefore, this is 103 degrees. I also know that these are same side interior angles, and the two lines that are forming them are two parallel lines and this transversal. Therefore, they would be supplementary. Also, I know that these two lines are parallel, being cut by a transversal, then same side interior angles are supplementary, and this would be 77 degrees. Also, I could have said a definition of a linear pair. Again, they want me to find the measure of each angle in the diagram. I'm going to start with 40 degrees. I know that these two angles are vertical angles, therefore I know they're congruent, so this is 40 degrees. I also know that I have a set of parallel lines intersected by this transversal. And I know that these two angles are alternate interior angles. Therefore, two parallel lines cut by a transversal, then alternate interior angles are congruent. I also know that I have a pair of parallel lines here. When two parallel lines are cut by a transversal, these alternate interior angles are congruent. So this is 40 degrees. Now I have a measure of this angle that is 110 degrees. I know that this angle and that 110-degree angle are corresponding angles. Therefore, they are congruent when these two lines are parallel being cut by transversal. So this has to be 110 degrees. The whole angle is 110 degrees. But part of this angle is 40. Therefore, this angle has to be 70 degrees. 40 plus 70 is 110. Now, I know that this angle is 110 degrees, and this entire angle and this angle are a linear pair. Therefore, this has to be 70 degrees. Now I can determine the measure of this angle because this is a linear pair, and this is 70 degrees. And I need one more angle, and that is here. I know that I have a set of parallel lines and a transversal. When two parallel lines are cut by a transversal, then corresponding angles are congruent. Since this is 70 degrees, this is 70 degrees. On this slide, they want me to find the value of x and the measure of each labeled angle. Here, I have a figure. I have two angles that are given to me, x plus 11 degrees and 2x minus 5 degrees. Two parallel lines cut by a transversal, then same side interior angles are supplementary. Therefore, x plus 11 plus 2x minus 5 must equal 180. And when I simplify, I'm going to get 3x plus 6 equals 180, 3x equals 174, or x equals 58 degrees. Now that I know that x is 58 degrees, I know that this angle has to have a measure of 58 plus 11, or 69 degrees. Since these two angles are supplementary, then I know this angle has to be 180 minus 69, which is going to be 111 degrees. On this diagram, they want me to find the value of x and the measure of each labeled angle. In the diagram, I'm given two parallel lines and a transversal cutting those two parallel lines. If two parallel lines are cut by a transversal, then corresponding angles are congruent. Therefore, 5x minus 22 degrees equals 4x minus 12 degrees. Solving, I'm going to subtract 4x on both sides, get x minus 22 equals a negative 12. Add 22, x equals 10. Now I define the measure of the angles. So 10 times 5 is going to give me 50. 50 minus 22 is going to give me a 28-degree angle. And I know that these two angles are congruent. So this angle also has to be 28 degrees. I can prove that by substituting in 4 times 10 is 40. 40 minus 12 is 28 degrees. In this diagram, they want me to find the value of x and the measure of each labeled angle. Here, I have a set of parallel lines being intersected by a transversal. When two parallel lines are cut by a transversal, then corresponding angles are congruent. So this is 110 degrees. I know that these two lines are parallel and being cut by a transversal. When two parallel lines are cut by a transversal, then corresponding angles are congruent. So 2y equals 110 degrees, or y is equal to 55 degrees. And the measure of this entire angle is congruent to this entire angle, which was 110 degrees. Following the directions from the last slide, again, I want to find the measure of each angle and the value of each variable. Since these two lines are parallel, two parallel lines cut by transversal, then corresponding angles are congruent. Therefore, x has to equal 90 degrees. I also know that these are a linear pair, so 3y equals 90 from 180, leaves me 90, and y is equal to 30 degrees. And I know that this entire angle has to be 90.